Today I'll present ARC, a tool to rate AI models for robustness through causal analysis. Robustness here encompasses both bias from protected attributes and model stability under perturbations. Let's start by choosing a task. Here, let's start with binary classification. We can choose the pre-existing German credit dataset, which contains information about 1,000 customers with attributes age, credit amount, gender, and risk. The dataset is used for credit risk analysis and classification. We can choose one or more protected attributes over here. Let's go ahead and choose age for now. We have two systems available here that we can evaluate. Let's choose both. And here we have an option of selecting the metric. For example, deconfounding impact estimation uses G computation technique to estimate causal effects. It assesses the impact of confounder on the relationship between input and outcome variable. Here are the results, and on the left you can see the log of the options we have selected. On the right side you can see the corresponding causal diagram for this task, and at the bottom you can see the main results, which consists of the partial order that quantify this metric, and based on those our tool computes the final ratings. Let's now explore the task of time series forecasting. Here we have stock prices data obtained from Yahoo Finance for 6 companies across 3 industries, and we subjected this data to 2 semantic perturbations, 2 input specific perturbations, and 1 composite perturbation. More details are available in our paper. And in the attributes, we have the option of again choosing one or more protected attributes. So let's choose both industry and company. And we can select one or more models for evaluation. ARIMA is a statistical model. Biased and random are the baselines. Whitnam spec are vision transformer based models trained on pre-COVID and post-COVID stock prices data sets respectively from Yahoo Finance. Again, we can choose any of the metrics. For example, propensity score matching deconfounding impact estimation here uses propensity score matching method to compute die percentage score. This is similar to how randomized control trials works, but this works with observed data, and it only works with categorical input variable. Again, we can see the results over here, the quantified pi percentage scores, and then based on that, the final order consisting of ratings given to each of these AI models or time series forecasting models. We can also use ARC to evaluate custom models on a custom dataset. So let's go ahead and choose a custom task. Now we can upload our own dataset. I have a sample dataset with me here. So let's go ahead and choose that. And now we have the option of choosing one input which acts as a treatment. And we can choose any number of protected attributes here. So let's probably choose 2. And we also have the option of selecting different predictions generated from different AI models we want to evaluate. So model 1, model 2, model 3 refer to these outputs generated from those models. And our effects are computed within this fixed causal setup so that we don't have to test everything under the sun. We have already chosen the system prediction, so we need not choose anything over here. And this time around, we can choose weighted rejection score as our metric, which computes the statistical bias exhibited by different AI models. And you can see the quantified statistical bias or the weighted rejection scores here, and the final ratings given with respect to these protected attributes for these different models over here. That's the end of our presentation. Thank you.